Alright, this unit we're going to be talking about quadratic functions. See, quadratic functions. It's going to be very similar to what you saw in absolute values. The only difference is the actual look of the graph. But you should see a lot of things that should be familiar from the first unit. First up, we're going to look at our parent function, which is f of x equals x squared. And if you graph in that handheld device that you have, also called a calculator, if you put y equals x squared and graph it, you'll see that it's going to be a parabola shaped that looks something like a U. The absolute value equations look more of a V and actually had a tip, but this is going to be a fluid U-shaped, what we call a parabola. If we look at the characteristics of our quadratic function, first things first is I want to start off with our vertex. The vertex to me is going to be one of the most important pieces of our graph because it's going to tell us our most information. Our vertex is going to be either the bottom or the top of the U or N depending on which way the quadratic function is going. In this case, you can see that it's going to be at 0, 0. From our vertex, we can learn a lot of information and tell what we're going to go to next. If we look at our domain, remember from the absolute value, our domain, if we look from left to right, we can see that it's going to go forever in the left direction and forever in the right direction. So that's going to be from negative infinity to infinity, or as a shortcut, all real numbers, which is this capital R with a little line next to it as well. If we look at our range, remember from the absolute value equations, we start at the bottom and we look up. So if we start down here and we look up, we're going to start at right here 0. And the 0 is going to be in a bracket because we are including this 0. Now as we go up, we can notice that we're going to keep going on in the infinite direction. So it's going to go from 0 to infinity. Make sure your doesn't look like an 8, looks more like that. And we're going to keep a parentheses over here because remember you can't actually reach infinity. Now next we have the x-intercept and the y-intercept. This should be pretty simple from our parent function because it touches the x and y-axis at one point. The x-intercept is going to be right here at 0, 0, and our y-intercept also is going to be here at the origin at 0, 0. Now if we look at our increasing and decreasing values, we can see that, okay, if we start from negative infinity and follow the graph, we're going to be decreasing all the way to 0. So I'm going to start over here at negative infinity, and I'm going to decrease all the way to 0. Once we get to 0, remember this is going to be a parentheses, not a bracket, because 0 is not going to be included. This is going to be where we're going to be switching from increasing to decreasing. If I start right here at 0, I notice from 0 on to infinity in the x direction that we are going to be increasing. Now if we look down here, the next part of our worksheet, we can see transformation of vertex form. This is going to be very, very familiar to what we did with the absolute value equations. If you look at the f of x equals a parentheses x minus h all squared plus k, this is going to tell us a lot of stuff. First things first, just like in the absolute value equations, this a is going to be a vertical shift or vertical compress. Remember that if it is a fraction between -1 and 0, not including -1 or the 0, or from 0 to 1, this is going to be a vertical compress. If it's anything larger than 1 or smaller than -1, it is going to be a vertical stretch. Obviously right now we're looking at stuff in the positive direction, or a being positive, so this is going to be a graph that sort of looks like this, and it's going to what we call open up. Also, this is going to give us a point down here, our vertex, which is going to give us a minimum. If we look at a being negative over here, what the negative is going to do is it's going to reflect over the x-axis. It's also still going to give us a vertical stretch or vertical compress, but instead of looking like a U-shaped, it's going to look like a N-shape, where that is going to be our vertex. This is what we're going to call we're going to say is opens down. This won't give us a minimum, but instead if we look, it's going to give us a maximum. Now if we look over here to h, just like in our absolute value equations, h is going to give us a shift going left or right. If we have a negative number, this is going to make us shift to the right. If we have a positive number here, if it's x plus something, that's going to make us shift to the left. This is going to be a horizontal shift. Now outside we have a plus k. What this k is going to be a vertical shift, which is going to give us up or down. And up is going to be in positive direction, so it'll be plus, and down is going to be a minus. This equation is going to be very, very important for us to look at, and we're going to see this in the next example.
And please do not misspell axis like Mr. Griffin did.
AX. Oops. Although this handwriting is a little bit neater than the last time, a little bit bigger, please don't mind the correct spelling here. But if we look over here, our first example is f of x equals 2, parentheses x minus 3 squared plus 2. First thing first, before we do the graph, we want to look at what's going to happen. This 2, our a term, is going to be a vertical stretch of 2. It is positive, so it is going to be a U-shaped. The minus 3 here is going to give us a shift, and it's going to be our left to right shift. Since it's going to be minus 3, we're going to be shifting right 3, and the plus 2 here is going to be either up or down, and since it's positive, we're going to be going up 2. Once we have our transformations, the right shift and the up shift are going to be a good indication of where our vertex is going to be. Since we're going to be going right 3 and up 2, that right there is going to tell us where our vertex is going to be here at 3, 2. Now the next thing we can look at is our domain. Our domain, just like the last time, and for any quadratic that we do, is going to be either from negative infinity to infinity, or again, all real numbers. Our range, our vertex is going to tell us a lot about our range too. We know since this is a positive and it's going to be going up like this, we know that our range is going to be from our y value here at 2 all the way to infinity. Remember, the bracket is over the 2 because we are going to be including that point as well. So it's going to be 2 to infinity. Our x-intercept, we're going to get into that in a second. We can actually do this using a calculator, or if we wanted to, we could probably do this in our head just by solving the equation and finding the roots. Now, looking at our graph here, this one should be fairly easy because if we don't cross the x-intercept, then we're going to have no x-intercept. Now, if you have one that actually crosses the x-axis, let's say that we have a vertical shift of minus 2, which means we're going down 2, then you can solve for the roots like we did last equation in order to figure out where it crosses. Our y-intercept, all we have to do is take our x here and plug in a, actually doing it on the calculator would be a little bit a little bit easier, but we could plug in for our y-intercept. Our y-intercept is where our x value is going to be 0, and so what we had to do is plug in a 0 here. So if we say 0 minus 3, that's negative 3. Negative 3 squared is going to be 9. 9 times 2 is 18, and then add 2 to 18, we can get 20. So our y-intercept is going to be 0, 20. Remember, we get the 0 from we plugging in our x value where it crosses the x-axis. The increasing and decreasing value as well can be found from our graph here. We know that our x value here, our right shift 3, is going to be the spot where it switches. So if we look at our graph, we're going to be decreasing here from negative infinity all the way to 3. Remember, we are going to keep these in parentheses because we're not actually including them. From 3 on to infinity, we are going to be increasing, so that's going to be our increasing. All right, the next part says, write an equation of the quadratic and vertex form given the following information. Like I said before, the vertex is going to give us something very, very important. That's going to tell us a lot of the information. We know that we're going to have an equation that's always going to start off with either f of x equals or y equals. In this case, we're going to do y equals. We know that our 2 here is going to be our horizontal shift, and since we have a 2 here and it's positive, we know that we're going to say x minus 2. The squared here is what's going to give us our quadratic equation, so make sure you don't forget that squared. The 3 here is going to tell us to go up 3, and that's going to be our k term from the previous 2 problems. So we're going to put plus 3 here to tell us that we're going up 3. This opens up is going to tell us that it's going to open up similar to this right here, so we know that our a term is going to be positive. Since we know that, we can tell that our equation is going to be y equals x minus 2 squared plus 3. Now, for problems 2 through 5, go ahead and give those a try and review those in class tomorrow.